Hello everyone. We are going to learn today about arithmetic progressions, also called arithmetic sequences, and a bit later about arithmetic series. I remind you that an arithmetic progression is one where each term is equal to the previous one added the same number, called common difference. For example, in this sequence, the first term is 3, the second term is 7, and as you see, every time I add 4. So the common difference is 4. We have a general notation D for the common difference, but it really doesn't matter what notation you use. As some of you know, there is a general formula to find directly the nth term, and I can find it looking at pattern. So if we start with u1, and then we think that u2 is u1 plus a common difference D, and then u3 is u1 plus I add one more D to u2, and then u4 is u1 plus 3D. As you see, the general formula will be un is the first term plus n minus 1 times the common difference. And this holds for all n bigger or equal than 1, and n it's a whole number. On the next slides, I'm going to solve a few examples. I advise you, with each of these examples, stop the movie and try it yourself. Let's read the first question. What is the fourth term of an arithmetic sequence with u1 equals 300 and d is negative 5? So the fourth term will be u1 plus 3d. 300 plus 3 times negative 5, giving me 285. Please stop the movie and read this question. In any question on arithmetic sequence, if I know the first term and the common difference, I know everything about the sequence. So let me map the information given in the equation. The fifth term is 7, and the eighth term is 16. What is the 100th term? My idea is that if I know u1 and I know d, then from this information I can find u100. That's my plan. So I can approach it in two ways, either using the formula, so u5 is u1 plus 4d. u8 is u1 plus 7d. And solve simultaneous equations. So subtract 3d equals 9, therefore d equals 3. So u1 equals 7 minus 4 times 3, negative 5. Therefore u100 is u1 plus 99 times d, whatever it gives me. It is often useful just to take it intuitively. And let me think in this way. If this one is u5, and that's 7, I have u5, u6, u7, u8, u5, 6, 7, 8, u8. And I know that u8 is 16. So here I have plus d, plus another d. So see how the difference between 7 to 16 is 3d. So 3d will be 16 minus 7. 3d will be 9. So that's an intuitive way of approaching it. And it's okay to make sense of math problems rather than jumping into equations, especially helpful when questions get more tricky. The movie and try this question now. I always map the information given into math equations. First term is 5, common difference is 7. What is a term corresponding to the value 355? So I know that un is 355, and I need to find n. So u1 plus n minus 1 times d equals 355. And then that's how we solve the equation. Please notice that the term 355 is on the 51st position. If I was asked for the value 356, I would have gotten a decimal here, so I wouldn't have such a term. So I need to get a whole number here as a position for the term 355. That's a bit more challenging, more of a challenging problem. So try to stop the movie and try it yourself. What do we know about an arithmetic sequence? That the difference between any consecutive terms is the same. So a minus b, let me write the terms. First is 2a minus b, 2a plus b plus 7, and a minus 3b. So I know that it's arithmetic if a minus b take away 2 is 2a plus b plus 7, take away a minus b. And also, I can go with the difference between these two equals the same as the difference between these two, but let me act smarter and take these two because it's simpler, and these two. So, a minus b minus 2 is a minus 3b minus 2a plus b plus 7. And I analyze, I have two equations, two unknowns. So I should be able to find the unknowns. Please pause the movie and try yourself. And here is my algebra, plus checking the answers to check that the four numbers are in an arithmetic sequence. I'll start by telling you the story of the great mathematician Gauss, who was a child prodigy and helped his father with his accountancy. When he was 3, the story goes that he found mistakes in his father's calculations. And when he was 7 and went to school, of course he was a naughty child because he was very bored during math class. So the teacher gave him to calculate the sum, 1 plus 2 plus 3 plus, and add all the numbers up to 100, hoping to keep Gauss occupied for a while. But Gauss immediately came up with a solution. So what he thought was that this sum is S. And he wrote the same sum the other way around. 100 plus 99 plus 98 up to down to 1. So instead of adding on the horizontal, he added on the vertical. So here is a group of 101. And here is another group of 101. And here is another group of 101. So each of the groups will make 101. So if he adds two sums, he will get 101 100 times because there are 100 groups. So Gauss concluded that the sum of all numbers from 1 to 100 is 101 times 100 over 2, which is, I think, 5050. That's how quickly he came with a solution. And this prompts us to find the sum of the first n terms of an arithmetic progression. Let's assume I want to find Sn, which is u1 plus u2 plus u3 plus un, where un is u1 plus n minus 1d. Let me rewrite this sum in the following way. Sn is u1, that's the first term, and now u2 is u1 plus d. u3 is u1 plus 2d. u4, it's u1 plus 3d. Up to the very last one, which is going to be u1 plus n minus 1d. following the same logic as before, I rewrite the sum the other way. So I will write un here below this one, u1 plus n minus 1d, plus below this one I write u1 plus n minus 2d, the one before, plus u1 plus n minus 3d, and so on, up to the very last one, which will be u1 plus d. Oh no, sorry, u1 is the last one. Now, if I add in the same way as before, and I add these two, I get 2u1 plus n minus 1d. If I add these two, I get the same, because each of the terms up increases by a d, but each of the terms down decreases by a d. Therefore, their sum will always stay the same. So 2sn will be 2u1 plus n minus 1d n times, because I have n terms. Therefore, Sn, the sum of the first n terms of an arithmetic sequence will be, let me rearrange, n over 2 times 2u1 plus n minus 1d. And that's a formula for the sum of the first n terms of an arithmetic sequence with a common difference d and first term u1. Another version of it is that if we think of this as we split the u1 into u1 plus u1 plus n minus 1d, and see how this one is un. So another version of the formula is n over 2 brackets u1 plus un. First term plus last term times the number of terms over 2. So both formulae are correct. I want you to check in your formula booklet to see which one you have in there. Let us apply this. Please read the question and try it yourself. All multiples of 3 between 100 and 1000. So 102 is the first multiple of 3. 105 will be the last one, up to, and the last one will be 999. So I need to find the sum of all these numbers. Now they form an arithmetic sequence with the first term is 102, the common difference is 3, but I need to see how many terms I have. So 999, which is u1, will be u1 plus n minus 1 times d, and this will help me find n. As you see, n equals 300. So Sn, the sum of the first n terms, will be 300 over 2, and I can use either the first formula, 2 times 102 plus n minus 1 times d, and you can calculate, or you can use n over 2 brackets u1 plus un. Both of them will give you the same answer.